So now we get into the fun part, seeing if any of what we've done works. If I go to Administration and Settings, underneath the Protocols and Radius, there are options here to suppress repeated failed clients, reject radius requests from clients with repeated failures, and suppress repeated successful authentications. When I'm doing testing, I like to shut these off because it will create new log entries in the live log for each attempt, so I can better see what's going on. Otherwise, what we see in the logs which right now is nothing, will show repeated and a number of times. You can click on the client and tell it to suppress that so that you can troubleshoot a client directly if it's a live network and you obviously don't want to go shut that off. So now we can go ahead and start testing some devices. I'm going to swing around here and start to go ahead and plug in a device. It's going to be a Cisco phone. I'm going to look at terminal monitor here so we can kind of see what's going on the switch as this happens. I'm also going to set my refresh rate over here to every 5 seconds. I'm also only looking at the logs that have shown up here in the last 60 seconds. So if I plug this guy in, so whatever port this ends up being, should see it over here on our switch, 1031. So again, this is one of the ports between 25 and 36 that is configured for closed mode. Once this phone boots, we should see a .1x failure here on the switch, because of course the phone is not even going to try to do .1x. And once we see that, we should see some information in the logs here. There's our fail. And here we are. But we hit the default policy rather than that wired policy that we built. So if we look in our report here, our authentication was default MAB, our authorization was the default, and we got to deny access. But why? So over here, if we look at our policies, we ended up hitting this guy. When we look in here, we obviously went through MAB, we saw that. We came down here and we ended up hitting default. It's the only one available. Now, I will say, in ISE, by default, this policy has a number of these enabled. So, brand new deployment, you've got to be careful. This basic authenticated access with permit access is enabled. The Cisco phone and a number of these are enabled. I guess I didn't show it in the videos anywhere, but I went through and disabled all these. So at the end of the day, if I don't match the policy that I created and I hit the default, I'm simply going to get denied. If we go back and look at the live logs, again, that's exactly what happened. But the question then is, why did we not hit the proper policy set? So here, the only thing that would make it hit this would be, is it MAB or .1x, and the keyword there being or. I have and I make this mistake in ISE all the time. It's a default to and, we want it to be or. So before I switch that, I'm going to come back over here. Whoops. I'm going to shut this port to kill the phone. I'm going to save this. And I'm going to go out to my endpoints. Thought I saved it. There we go. And I'm going to delete that phone. So here it is. These endpoints get automatically created when I seize devices. And I want to delete it just because I want to make sure that end to end, if this phone was a brand new device, ICE knows nothing about it, it comes on and it does all the right things. So sometimes you can get in a position in testing where all of a sudden something works, and then you plug in another phone and it doesn't work. And that's probably because something happened here, and that, ICE had some information to make decisions about that device. So looks like it is gone now. And if we go back over to our live log, and we do a no shut, we should wait and watch this guy boot up again. So there's our failure. Next reload here, we should see what happened. There it is. All right, there we go. So we hit wired MAB on the authentication. We hit our wired profiling and return the profiling result, exactly what we would expect. This is our DACL. All right, so if we come down here, we can see this is what was applied in the DACL. And we hit MAB, wired profiling again. Now, I would have expected that this would have hit our phones policy after that. But there is something we didn't do. I did this on purpose to show you, because again, ICE by default, out of the box, doesn't have this turned on. So COA is our change of authorization, right? We have to be able to send back to the switch something to tell the switch that, hey, this device needs to re-authenticate because we changed what it is, and that could possibly change what policies it hit. Again, by default, that doesn't happen. So we're going to start over. And you can see this guy's going to try over and over again to try to authenticate and connect, but we're never letting it on. So I'm going to shut the port. We're going to go into our endpoints again. We're going to delete him. And then we will look at our profiling. So under settings, work centers, profiler, and settings, the very first thing we see is COA type. And by default, it's set to no COA. Our options are port bounce or reauth. Now, reauth is going to send information to the switch telling it, hey, you need to, perform reauthentication. A port bounce is going to do exactly that. It will actually shut the port. If it's a PoE device, it gets powered down, powered back up. We'll go ahead and choose reauth here and save that. Now, if we go back over to our live log, let's go make sure that deleted. Pretty sure it would have. Yeah, no phone here. We'll bring this guy back up yet again. There's our failure. We saw it hit the profiling. We sent the COA, and now we can see wired MAB. We hit wired phones, and we turn the phones to voice. So if I look at see here, we're in VLAN 3. It says here that our phone got 3.10. Sure enough, it's online. So if I stop this from refreshing and we take a look at some of this in a little more detail. So the first MAB auth came in, we can see here, we hit wired MAB, it hit profiling, we get a whole bunch of information. This is that accounting data that sent back or got sent back from the switch, right? So we can see we received all of this information about the phone. And down here, our result was VLAN override to 7, deny all the access. Our next list is our DACL download. So our download succeeded. Here's our DACL. No food for you. The very next is the COA. This is what wasn't happening before. And we sent our COA to the device to tell it, hey, reauth. Then, on that reauth, this time, we knew it was a phone. If I go back to the top, still went through wired MAB. This time we hit the phone's policy and return the phone's voice result, which our result here, set it to device traffic class voice, and away we go. And the very last one is just informational. So that's our phone. Got online, everything's looking good. Let's move on. I'm going to go ahead and reach back around here and plug in a wireless access point. Should be into port 32. If we look at our switch, yep, we see 32. While we let these guys take a minute to boot. Seeing the port bounce a little bit here as the AP boots. There it is. Next refresh we should see some information back here. We did. We hit the profiling, returned our ACL just like we did before. Now we hit MAB, access points, wireless APs, and it got an address in 410. So let's take a look at this too. This is all going to be the same as the phone, right? We returned the profiling ACL. We sent back our COA, phone reauth, or the AP reauth. This time hit the access points. Looks like we got another COA. And it ended up coming online. So again, here we can see all this information we found and received about the AP. If I look at the original session, so the AP is good, and it's online 4.10. We should be able to come over here. Ping him. He's online. All right, well, let's move on to our printer now. I'll go ahead and get him plugged in. And over here, we should see our port come up. I don't leave that printer on, so I had to turn it on. There we go, 1033. We should see our auth failure here shortly. There it is. I'm back over here. We hit the profiling. I lied to you earlier. So here's what's happening here. HP device. The policy that I added, or the profiling policy that I added the printer to, was HP LaserJet printer. So we are not getting enough information about the device. Let's go ahead and let it on. So what I'll do here, let's go into my policy set for my printers. I'm going to switch this to OR. HP device, use, save. And now we should see, I'll just go bounce the port manually here. This time right away when it comes up, should hit our printer's authorization policy. There's our failure. We should see something new here. And there we are. It hit the printers. And then we see that it figured something out. So we know with our initial policy here that there is something that was preventing ICE from getting the information it needed. So I wonder in this scenario, if I allow DHCP on my access list, what would happen? So let's go in here. Go to our results, our downloadable ACLs, and before the deny any, we will permit we'll let the device send DHCP. Maybe this access list was actually blocking that. I did notice in the ICE support site that I had referenced earlier, they did have this in here, but I didn't think that it was necessarily required. So now that we've saved that, let's go back to our endpoints. Let's find our printer. We will delete that. Come back over here, bring this guy back up. Go take a look at our logs. Wait for this guy to boot up and see what happens. There's our interface up, and you can hear the printer whining behind me here. There's our fail. Let's see what happens. So let's stop this. On our initial auth, we didn't learn much. Same as before. Put on our access list, sent our COA. On our second auth, now we saw this DHCP information, and we saw a host name, the identifier, that's funny. This is my wireless network. It requested that address. Of course, it didn't get it. Then we should have sent COA again. Had to refresh this. And sure enough, it came on in VLAN 5. So the question is, why did our phone and our access point work, but our printer didn't? And for the video, this was somewhat by design. When we configured our switch, we configured a bunch of different sensors and information to be able to send back via those accounting messages to ISE. Those included CDP, LLDP, and DHCP. Well, both of those other devices, the phone and the printer, or the access point rather, sorry, the phone and the access point, both being Cisco devices, could do CDP and LLDP probably. So we didn't need that DHCP information from them, right? If I was to go back in my logs here and look at one for my access point, we can see here a lot of the data we received was from CDP, LLDP. So the DHCP just never came into play up until our printer, which didn't do either. So let's try another device. I have a Polycom phone behind me here, and I'll plug that guy in. Okay. So we see here, forgot to turn on terminal monitor. Looks like that phone is booting. Now the Polycom phones, if I recall right, they will do LLDP, so we should get data there, and that whole issue with the printer and DHCP data in the ACL shouldn't apply here anyway. There's a fail. Whoops, I didn't have this refreshing. Get our profiling. Came back to profiling. What we see here is Polycom device. So with a Polycom device, I don't believe that was allowed in any of our policy. So let's go take a look at our policy. IP phones. So if we come over to our profiling policy, I believe that's under here, IP phones, contains Astra via Cisco, whatever IP-phone is, and Nortel. This is default. We do not have any Polycom. So here, the other thing we can see is, unlike Cisco and probably Avaya and others, we don't have any specific makes or models of Polycom devices here. And ultimately, yes, I could just move this over to this policy and we would start hitting it and things should work. But in this scenario, I want to highlight how it is that we would hone in on a device and figure out specifically what to do to create a more specific profile. So if we come back over to our logs and we look at this device and we go back to what we see, here's the information we've learned, again, a lot of it from LLDP. We've got a system description, a system name, capabilities. In this case, I'm going to assume that the LLDP system name is the factory default name of the phone. So I wouldn't want to key in on that, because if it joins a phone server of some sort, gets a new name, desk 231, all of a sudden my profiling for that device is broken. Where I believe the system description is not something that's probably going to change. So in this case, we're going to go back over to ICE. We're going to go into the policy elements, and these are all those checks that we can do on devices. So here, if I add a device and call it Polycom VVX, and I'm going to say that LLDP, what did I say that was? That was the system description. And we'll say it is going to contain Polycom VVX. And the idea here is, if I had 500s, 600s, whatever other models there are, I would be able to group all of them into a Polycom VVX profile, right? I could go as far as to cover the actual model number and create one for each model, very similar to what was done for Cisco phones. But in my case here, I'm just going to key in on this VVX. So we'll put that over here. We'll submit that. Then underneath our profiling policies, we are going to add a Polycom VVX here. We want the parent policy to be Polycom because we know that that is being hit. And in our condition, VVX, certainty and factor increases 10, minimum is 10. So on top of already knowing it's a Polycom device, if it matches this condition, add 10 to the certainty factor, which would hit our minimum here. And again, we could have multiple conditions. I could do 5, 5, and something, whatever it is that I feel comfortable with to make sure that I know that this device is indeed a Polycom phone. So if I submit this, and now we have to do one of two things. And again, this kind of gets into how do you want to handle this in your environment. I could go over here to my logical profiles for IP phones, and I could say Polycom VVX, and I could add it. Or I could just go change my rule altogether and say, hey, I'm going to write a brand new rule that keys in on the Polycom VVX and provides the same result as my Polycom or as my IP phones. But in this case, I'm just going to add it here and save it. So now let's give this guy a run at it again. If we go to our context visibility, I thought I may have already deleted it. Yep, it was always at the top here. Go over to our live logs. No shut this guy. There's our failure. So I'd hit the profiling, get profiled as the VVX. You should see a COA sent back, and that guy should come online. So there it did. It says 172.16.3.11. If I try to ping that, it is online. So now let's try a completely obscure device that ICE may not know anything about. This, you can run into a lot of times in medical, a lot of medical devices and different things. ICE has got a plethora, as we've seen, of different device types that it's going to, at least at a minimum, find based on a Mac OUI that, it's a Polycom device or a basic HP device, and we might have to increase on that a little bit and get it more granular, whatever that might be. But when it comes to devices we don't see very often, then it may show up as an unknown device. So I've got a silicone dust HD home run device here. It's just a little box that takes over-the-air antenna TV, turns it into network so you can plug it into Plex and different things like that and watch OTA TV. So I'm going to plug that guy in and bring him up and see what ICE thinks of that. So I think that guy should come up. Yep, on 134. See, the network light is blinking, so we should see an auth failure here shortly once it realizes .1x isn't going to happen. There it is. We get wired profiling, wired profiling. We don't really see anything about the device. Let's go take a look at it over here. What was that MAC address? Ended in 182B. There he is. Did get a host name out of it, but endpoint profile unknown. So in this case, ICE knows nothing about what this is, not even Mac OUI information. So let's go take a look at the information that we do know about it. If we come into our attributes, we can see, tried the SNMP query probe. It did catch and know that the OUI was silicone dust engineering. However, we don't have any checks for that. If we look at our logs, we're not really getting a whole lot from that guy. So really all we have to work with in this case is that OUI right now. So let's go ahead and create rule rule 1, check 1. Here we're going to say Mac OUI equals this. Submit that. And then of course we have to go over to the profiling policies. And we'll call it silicon dust device. Check 1 plus 10. I'm not going to create an identity group for this. We can use this to create specific groups for specific devices, and then those devices get put into that group. A way to logically separate them into their own identity group. We can of course use those identity groups and rules. In this case I don't really need that. There is going to be no parent policy in this scenario because there isn't one. This would be the parent. And we'll submit that. And now we have to go fix our rule set. So policy sets. If we come in here, I am going to just copy this printers, duplicate above. We'll call it silicon dust. And in here it is going to be endpoints policy silicon dust use, and I'll just drop it into the printers VLAN. That's fine. So we'll save that. Now if we come back over here, we can see in the background I didn't do anything. It already found it and figured it out, but we're still hitting profiling yet. There was no COA sent, so I'm going to just bounce that port and we'll see what happens. There we got our failure, and sure enough it went into printers. So it did exactly what it was supposed to do here, and it got an IP address. So that looks good. Now again, one of the things that I always like to do is go delete the device and let it come on brand new, just to know that, you know, sure I made this work, but is it going to work end to end, start to finish on a brand new silicone dust device that I plug in. So if I shut this port again, I come back over to here. Should stick out like a sore thumb now here. We'll delete this guy. Go back to our live log. No shut the port. There's our failure. Profiled it. Got a COA, came online. So we should be able to ping that guy. And we can. So the question now is, you know, did we get any additional information about this device? And it doesn't really look like it. I mean, we've got a system name, but I don't know if I trust that. Again, it could change, I would think. If we go look at the endpoint, that's about all we get. So if we're comfortable with this, we can of course leave it the way that it is. Other things that we could do would be to change the result in this scenario, where if we see this MAC OUI, we go ahead and let it on, but again, we can apply an access list to lock it down, make sure, you know, maybe it only gets internet access or whatever it might be. In addition to that, right, we can do specific MAC-based filtering. I could go create an identity group, put this MAC address and this device in it, key in on that group. Again, that's just MAC-based filtering, but at least at this point we know we were able to write policy to let this on, although in this case the device didn't give us a whole lot of information in DHCP. I think overall, you know, medical devices and different things like that, they'll at least, very much like my printer, return some sort of data that we can key in on and be a little more sure that the device is what it is and we can handle it properly. So now we should be able to move on to our actual .1x authenticated PCs and users, our top two rules we created here. And I know for a fact, before we get started on that, there are some changes we need to make for it to work. I believe by default user authentication would work just fine, but I don't believe the certificate for the computer would authenticate correctly, and this is something I kind of addressed earlier underneath our identity stores and this NetTech cert. We've got this set for common name only, and we chose common name in the cert to be delivered for users, but did not set anything there for computers. So here we are going to need to switch this, and again it does say for Active Directory only. You can kind of read here that it basically allows ICE to search on any of the certificate services here. So now that that's done, there are a number of things that we need to do for the Windows device to be able to utilize, or tell the Windows device to utilize EAP-TLS and some sort of .1x auth method against the switch. And the most common way is, yet again, using group policy to push the information to the PC on how it should configure its network interface and what it should do. The other piece to that is, in order for Windows to authenticate, we have to have this wired auto config service running. And it appears, based on a brand new install of Windows 11 like this, that at least here, that is set to manual. So even if I go configure and push those configurations, nothing's going to work unless this service is started first. So I'm going to jump into my domain controller here. And we are going to open up the group policy again. And in here, we created this certificate deployment one earlier. Now, again, depending on your Active Directory, you may already have a policy that makes sense to put this information in. But for me, I'm going to create a new one. Call it knitconfig. And in here, I've got to do a couple of things. All under the computer policy, all under security. The first thing I'm going to do is go into the system services, find my wired auto config, set that to start automatically. Then under this 802.3 policies, I'm going to create a new wired policy. I'm going to call it EAP-TLS. Over here, we want to do smart card or certificate, which is EAP-TLS, and I'm okay with, user or computer. I can choose one or the other, but per the previous conversation we had about that, I want both. I want the machine to boot up. Before login, it will use the computer cert. As soon as it logs in, it should use the user cert. So in my properties here, there are a number of things I want to do. We want to verify server's identity by validating the certificate. And the only trusted root authorities I have are this AAA certificate services, right? This is the outer method. This is the authentication of the server by the client. Do I trust you? I used a public cert. I should only have to check this one, but if I go down, I'm going to grab these user trusts and the Sectigo one as well. So at the end of the day, when this computer connects, if it's not hearing back from ISE with one of these trusted root authorities or a cert that's one of these trusted root authorities generated, it's not going to trust it, it's not going to connect. Now on the inner method, where my computer and my user are using a cert for PKI, or from my PKI, from my certificate services, here I'm going to check my networktech.net. So again, when the client tries to authenticate, we only want him to authenticate if the server is trusting the. So we'll apply that. I'll close this and we'll go verify that all of these changes have propagated. So here, if I do a GP update force, once this completes, over here, I should see that this service has started. And it did once I refreshed here. And then if I look at my group policy for my user, I should be able to see that obviously under system services, this was set by this GPO. Here we have our EAP-TLS. If I open it up, we can see again all of the information here that we set, again by this GPO. So we got the information we needed. Now, to test this, I am physically, I guess virtually and physically, going to move this machine's network connection from the VLAN that I'm on right now in VMware Workstation over directly to a physical adapter that plugs into my switch. We should see the network bounce when this happens. Down here, there it went. And assuming everything works, it should come back online. And there it did. If I do an IP config, I should be in VLAN 2. I am. Let's go look at ISE and see what happened. Here we are. We saw this authentication come in. Let me pause this. My username, EAP-TLS. I hit domain users. So we can see in all the steps what happened in a lot of detail. Looked me up in Active Directory, found me obviously, EAP-TLS succeeded, and even here we can see we get a lot of data about this device. Now we don't really care, we're not doing MAB, but nonetheless we do get a fair amount of data. If we go look at my client, we can see here my username shows up, the host name of my machine. It's identified via profiling that it is a Windows 11 workstation, and that I'm authing with PKI. If I click on this, we can see all the attributes, information about what Active Directory groups I'm a part of, just a whole bunch of information here. If we look at the authentication, we can see information about what happened in my authentication, all of the different steps. So that worked. Now the only thing we didn't see here is the computer auth, and unfortunately for that I'm going to have to reboot this computer so that we can see that in the logs, and of course this computer is also where I'm doing the recording. So I'm going to stop the recording, close everything down, reboot, come back up, and we'll go ahead and look in the live logs, and we should see that the machine came online, authenticated with the cert. Then I'm going to log in. Once I log in, it should switch over to my user. So I'll pause here. Okay, I just got logged in here. Obviously you didn't see it, but the machine booted up, came to the login screen in the bottom right. I did see my little network icon showing me access. So I assume things worked well. Let's go ahead and log into ISE. If I can type my password right. And head over to our live logs to see what happened. So we're looking at the last 5 minutes here. Let's go back a little longer. So here at 17, that was my initial test when I moved the machine over. I had rebooted, so we see the machine came up here. Now we see the identity being the host name at networkingtechnician.net, signifying to us that it used the machine cert. If we look over at our endpoint information, Windows 11, we hit EAP-TLS all along the way, but here you see we hit domain computers. I left it at the login screen for a couple of minutes. So here you see it set at the login screen. From here I logged in and it automatically switched over to my user cert. So here our authorization policy was hitting domain computers. Then when I logged in, we hit domain users. So that's working exactly as we would expect. Again, for this lab, I'm using the same authorization policy. It just allows me in VLAN 2. So that takes care of the EAP-TLS. Quite a bit easier once it's up and running than MAB. MAB, of course, we have a whole slew of different devices that we need to account for and manage. But this should end this video. I appreciate you taking the time to watch. Hopefully this was helpful.